Sometimes we are given the area under the curve and asked for the z-score or the x value. For this example, it says determine the z-score for each situation. And the first situation says 62% of the data is to the left of the z-score. So as we go to look at it, here's our bell curve. We know this is our mean. And recall, because it's symmetrical, 50% on this side, 50% on that side. So if I want 62 on the left, that means I'm going to be over here somewhere. So there's my z. I am looking at this area here being 62%. And what else do we know? We know that it's a z-score, which means mean is equal to 0. Standard deviation is equal to 1. Our area is 62%. So for a decimal, we're going to divide that by 100, and that would be 0.62. So as we go to deal with this question, we're going to use something called inverse norm. Okay, and our inverse norm, first item is our area as a decimal. The next piece is our mean, and then our standard deviation. So we're looking at inverse norm. For this one, our area was 0.62. Our mean was 0. Our standard deviation was 1. And again, like our normal CDF, this is the work. So this is what you need to show for your work. We are now going to our calculator to find the inverse norm. It's second vars, and you'll notice that right here, option number 3 has the inverse norm. So we're going to go down to that and hit enter. We're now going to enter in these numbers with the commas after them. So as we go to look at it, we have 0.62, comma 0, comma 1, close our bracket and hit enter. And when we do that, we get a number of 0.3054, and the number keeps going. When we look at z-scores go to 2 decimal places. So as I go to write this, I am going to have z is equal to 0.3. That 0 there has a 5 after it, which tells me it's going to round up, and I get an answer of 0.31. This situation says that 15% of the data is to the right of the z-score. So if we take our bell curve and we put our mean in, this direction is to the right. 15% is less than 50, so it's going to be on this side. So we can put on our z-score, and there is the shaded area of 15% to the right. Because this is a z-score, we know that the mean is 0 and the standard deviation is equal to 1. Now, one of the things about the inverse norm is the fact that the area has to be going to the left of what we are looking for, not to the right. So in this scenario, what we need is we need to know what that area is. We're not going to use the 15%. So we're looking at our area is equal to 100% minus the 15%. And as we go to do that, we're looking at 85% for our area. Divided by 100 gets us 0.85. So that is the value we are going to use with our inverse norm. So at this point now, inverse norm, our area to the left was 0.85. There, the mean was 0, and the standard deviation was 1. Now we've got our work done, we can go to our calculator. So as we look at our calculator, to get that inverse norm with second vars button, down to number 3, hit enter. And at this stage we are sticking in these numbers with the commas between them. So we are looking at 0.85, comma 0, comma 1, close the bracket and hit enter. And we get a z-score value of 1.0364. Now remember, z-score values go to 2 decimal places. So after the 3 was a 6, which means that 3 is going to become a 4. So we are looking at z equaling 1.04. Athletes should replace their running shoes before the shoes lose their ability to absorb shock. Running shoes lose their shock absorption after a mean distance of 640 kilometers with a standard deviation of 160 kilometers. Zach is an elite runner who wants to replace his shoes at a distance when only 25% of the people would replace their shoes. What distance should he replace his shoes? So let's start with our bell curve. Okay. And we're going to go back into the question and let's see if we can find our mean. So we've got shock absorption after a mean distance, there we go, of 640. So we know our mean is 640. We have a standard deviation of 160. Zach is an elite runner. He wants to replace his shoes at a distance when only 25% of the people would replace them. So now if we think about it, 25% of the people replacing their shoes would be the first 25% to replace them, not the last 25. The last 25 would be up here, the first 25 would be over here. It would be a low number of people and a low number of distances. So we're looking at this, where this is equal to 25%. We want to know what the distance is. Now distance would be an x value. So we want to know what the distance would be at that location. We are going to use our inverse norm. So as we look at it, we have our mean is equal to 640. We have our standard deviation is equal to 160. And we have our area is equal to 25%. And if we go and change that 25% to a decimal, divide it by 100, we get 0.25. So that means we have an inverse norm of 0.25, followed by 640 for our mean, and 160 for our standard deviation. So going to our calculator, we are going to go second vars, down to our inverse norm, number 3, hit enter, and we're going to put our numbers in. So our area was 0.25, our mean is 640 this time, and our standard deviation was 160. So when we look at it, we get an answer of 532.0816. So we want a distance of 532 kilometers. And that will be when he needs to replace his shoes. This was a word problem, so let's put in a word answer. Zach should replace his shoes after 532